One topic that often trips up statistics students is the idea of a type 1 and type 2 error. So, as you saw in our textbook, you can either have on the left is what's true. So, the null hypothesis, H naught, can be true, or the alternative hypothesis is true, which means the null hypothesis is false. So, either HO is true on top or HA is true on the bottom. Now, if HO is true, when we run our statistical test, we're either going to not find enough evidence to overturn our null hypothesis, which means we fail to reject the null hypothesis. This says accept the null. You actually don't want to ever say you accept the null. You want to say we fail to reject the null. We don't have enough evidence to say it's not true. Um, However, even though the null hypothesis is true, sometimes you might get a sample that's so extreme that when you do your statistical test, you have evidence to reject and you end up rejecting the null hypothesis even though it's true. Now, that's type 1 error. Now, on the other hand, let's say the alternative hypothesis is true. Even if the alternative hypothesis is true, a lot of times the difference between the null and alternative hypothesis might not be enough for when you run your statistical analysis. You might not get enough evidence in order to say this is conclusive proof. I need to reject the null hypothesis. So the alternative could be true, but you don't reject the null hypothesis. So you're not saying that the alternative is true, even though it is. That's a type 2 error. Now, if your alternative hypothesis is true and you reject the null in favor of the alternative hypothesis, well, that would be true. Now, here's an example, an analogy that I think is helpful using the criminal justice system. So Ben Franklin said something like, "It is better 100 guilty persons should escape than the one innocent person should suffer." And we kind of base our whole criminal justice system based off of that. So let's say I love Oreos and my wife accuses me of eating all of our Oreos all the time. It's usually true. Let's say instead I am accused of robbing a store or shoplifting Oreos from a store. Now, I'm going to go to trial for some reason. Now, the null hypothesis would be that I'm innocent because we always, in America anyways, we start with the assumption that you're innocent until proven guilty. Now, the alternative is that I'm guilty. I actually did shoplift those. You know they were double stuff, obviously. Don't even have to say that. That's the alternative hypothesis. So now let's say I'm innocent. So HO is true. Now, if we fail to reject HO, that means we didn't get enough evidence to say we're guilty. So basically, I'm innocent, and the jury finds me not guilty. Oops. And I love this analogy because just like saying we're found not guilty, we're not saying when we fail to reject the HO, we're not saying that HA is not true. It's just we didn't get enough evidence to overturn our presumption of innocence, our HO. Now let's say I'm innocent, but there's so much evidence that the jury convicts me. That means I'm innocent, but I'm still going to jail. Somebody planted some cookie crumbs on me. So innocent, found guilty. Now, let's say I did shoplift those Oreos, so the HA is now true. In this column, we're found not guilty. So even though I'm guilty, this is the best case scenario for me. I'm guilty, but the jury finds me not guilty. On the other hand, I could be guilty, but the jury sees the evidence and sees, oh yeah, definitely found guilty. He even lifted some milk too. Like, we have it all on camera. Definitely stole those Oreos. Now, in this analogy, and the way we always do this chart, if you make the chart, is type 1 error goes on the top right. Let me pick pink. So pink is type 1 error. That's when the HO is true, but you reject it anyways. And then on the bottom left, that's a type 2 error. Thanks for watching. I hope that helps.